So this is our free response question number 2, part A, and this is going to be our first method. We'll integrate it with respect to x. So to integrate this shape with respect to x, I need to know where this point is where the two graphs intersect, because I'm going to need to split this integral. So if we call this point A, then I need to do the integral from 1 to A, and then I need to know what this point is over here. It should be easy enough to find this point over here because we know that this is the line y equals 5 minus x. So since that's the line y equals 5 minus x, all I have to do is find out when that equals 0, and clearly that equals 0 when x equals 5. So this is x equals 5 right here. So this integral goes from 1 to a and then a to 5. And the top of this integral when we go from 1 to a is this function y equals ln of x. And when we go from a to 5, our top function is 5 minus x. So that means that we can just write that integral. In fact, we're going to do the integral from 1 to whatever that a is. And I'm going to go ahead and write the integral. You would want to find this a first, but I'm going to write the integral and find the a later. So there's integral 1 to a of ln x dx, and then I'm going to add to it this integral from here to here. That's the integral from a to 5, because I'm starting a going to 5, of 5 minus x dx. Now I need to find out what this point a is. So to find out the point a, I need to find where 5 minus x is equal to ln of x, because that will tell me where these two curves intersect. Now that's not an equation that I can easily solve analytically. In fact, possibly it could not be solved at all analytically. So what I would need to do is make a graph and see where the intersection point of the graph is. So I'll go to my calculator and I'll look at y1. For my y1, I'll put the 5 minus x, 5 minus x. And for my y2, I'll put ln of x, so ln of x. Then I'll want to look at how my window is set. And what I should do for my window is set it the same way their graph is, because we know we have a nice graph. We can see that their y goes from about 0 to 2, and their x goes from 0 to, well, 5 would probably be adequate. I'll have it go to 6. So we'll have our x window go from 0 to 6, and our y window go from 0 to 2. And I have both of the scales being 1, and we'll go ahead and graph that, and that looks a little different from their picture, but has sort of the same features. I think by going from 0 to 2, we've really exaggerated the height of this curve, but it's still the same curve. And they've also cut the curve right there, and that's why it really looks like this one. So we need to find the intersection point of those two curves. So to find the intersection, what we're going to do is second calc, and we will pick intersect. And we want to know if this is our first curve. So our cursor is right there. It's asking you, is this the first curve? Well, we only have two curves, so we'll pick that one. It asks us if this is the second curve. We say, yes, it is. It asks us for a guess, which is sometimes important. We want to put the cursor right there where those two graphs intersect and press enter. Now we have this point 3.693. So I now know that the a in this problem is 3.693. However, I can take advantage of the fact that this x is now stored as a value in my calculator. So when I set up this integral, I can in fact quit out of here and just say, let's clear all that. I can say, let's do the integral from 1 to that value x that I had in my graphing window, and that's what that x will represent. And then I'm going to put ln of x. Close that parentheses, and then dx. Then I can go ahead and add the next part of the integral, so I'll go plus the integral, so that's math 9 again, from that x point to 5, so we'll say from x to 5, and it's 5 minus x, so 5 minus x dx. So this pair of integrals should give me that total area. So I can just hit enter, and it tells me it's about 2.986. So we can say this is approximately equal to 2.986. Remember, we're using 3 decimal places for our AP response. We could just leave it 2.985. We can truncate instead of round. But that's our answer to part A using integration with respect to x.